radian is 3 pi over 2. Okay, so now I want you to know you want to read the PowerPoint, but if you already know something, you don't have to be reading it forever. There are angles called coterminal angles. So very soon we shall be talking about coterminal angles. What are they? I want you to make sure the things you can read from PowerPoint, read them. Coterminal angles are angles that have the same initial side, and that have the same terminal angles. All right, you see that this is 60 degrees. But if I go another round, I come back, another cycle, if I stop here, I have 420 degrees. Therefore, 420 degrees and 60 degrees are coterminal angles. 420 degrees and 60 degrees are coterminal angles. It doesn't matter how many times I go around the circle. So suppose I go 20 cycles. The important thing is that whichever one that passes through this terminal is a coterminal angle. And there could be gazillion number of terminal angles with the same as 60 degrees. The measures differ by a multiple of 360. Don't forget that. You cannot be missing a question that says coterminal. Coterminal angle means they have the same angle, but they differ by 360 degrees. All right. So we have said that, and you'll be seeing that in a test, by the way. You should know that it doesn't even mean so much. Let's see all those things we need to. We already converted from a degree to radian. You do the same if you're told to convert from radian to degree. They are showing you that you can use your calculator, but sometimes you're doing it by hand is quicker. If you can use your calculator, go ahead and do that. All right, so that is about. You will also be told to convert to radian. A whole lot of things you can be given a triangular. We come back to this linear speed very, very soon, so that I don't want to do linear and angular speed and somebody start. It's not that bad, but we're going to do that, get that later on. Quickly, let's go to a PowerPoint 9.2. That's where I'm going now. Second PowerPoint for this class is 9.2. So I will quickly go to PowerPoint 9. What is there? So every PowerPoint you need is already in PowerPoint 9.2 is this. Remember, we're supposed to get to 9.3 today. But we are going to we're doing our best, and very soon it's going to be 2 o'clock. But we're doing our best. Just know that if you read it up and you know it, there is no need. Okay, we talked about quadrantal angles, but there can be a triangle, a right triangle inside a circle. All right triangles inside the circle cannot be called unit circle. Suppose a circle has a radius of 5, then it's not a unit circle. A unit circle has a radius of 1. A unit circle has a radius of 1. So be careful. All you need is suppose, let me just draw one. Let's talk about one, because all circles are not unit circles. Let me make this one big so you see what they're talking about here, because it's in the test. Let's look at them squarely. I want you to see that they give you a point. The terminal side of this angle theta, the angle theta is an obtuse. It's actually an angle in the third quadrant. That angle is in the third quadrant, and the point is -3, -4. Find the value of the 6 trig ratios. Find the value of the 6 trig ratios. Let me go to my board. So I'm going to go to my board before. I don't have enough space here. And when I go there, I want to see, can you still see what I'm doing? I don't want to be talking to myself. So someone in this class, tell me, can you see my whiteboard?
Yeah.
Okay, great. Okay, suppose I have a circle. All circles are not unicircle. Let's start from a point here. Suppose I have a circle and the terminal side stops here, and the angle I'm talking about is theta. And if I make a right triangle here, if I make a right triangle right there, let me give this point 3, 4. It's in the first quadrant. So all the coordinates of the points are positive because in the first quadrant. Okay. And I can be told to find the 6 trig ratios because we have already talked about it today. I can be told to find the 6 trig ratios of this angle, which I call theta. I don't want to start with the one in the fourth quadrant, the third. So let me start with the one in the first quadrant. Also, what I can do now is, what I'm going to do is bring out this right triangle. If I don't want to bring it out, that's okay. I want us to know that 3 is for x and 4 is for y. And I want you to know that this is the radius, r. And because it's a right triangle, I can find the radius by Pythagorean theorem, like we just talked about. The sum of the squares on the legs is equal to the square on the hypotenuse, where the hypotenuse is the radius. And 9 plus 16 is equal to r squared. If you know what is Pythagorean triple, you already know it's 5. 9 plus 16 is 25. 25 is equal to r squared. So if I square both sides, I have 5. Therefore, the radius is 5. Well, the question is not about 5. We are not in a geometry class. The question is not about to find the radius. The question is find trig ratios of this angle theta. So I can say sine theta. If I can find sine, cosine, and tangent, I'm good. Because I know that cosecant, secant, and cotangent are the reciprocals. So sine theta is equal to, this is the theta I'm talking about, opposite to theta over hypotenuse, 4 over 5. 4 over 5. Therefore, cosecant theta is equal to 5 over 4. Cosine theta, I'm told to find the 6 trig ratios of this angle that is in the standard position and has a terminal at 3, 4. Cosine theta is adjacent to theta over hypotenuse 3 over 5. Therefore, secant theta is reciprocal of 3 over 5, which is 5 over 3. And then tangent theta, tangent according to SOHCAHTOA is opposite over adjacent. So opposite to theta over adjacent 4 over 3. Therefore, cotangent theta is 3 over 4. So I have found the 6 trig ratios of this angle. This is in your test already. So you will be given a point on a unicircle or a point on any circle. It doesn't have to be a unicircle. By the way, I just wanted to know that this is not a unicircle. A unicircle has radius of 1, but this circle has a radius of 5. So just so you know, all circles are not unicircles. Some are unicircles. Okay, so there is something I want us to talk about before it is 2 p.m. We still have a lot of time. have a lot of time because we have almost 30 minutes. Okay, so let me go back to, let me see if I can move this now. See if I can move. Sometimes this obeys, sometimes it doesn't. Let me see. Can you, oh, it's moving this time. Okay, so I'm moving this so I can write instead of putting another one. Okay, now what I want us to do is go back and solve the problem. Before I start, let me draw. All right, I drew a circle and I want to say all here. What does all mean? All students take calculus. All students take calculus. I'm just going to write, let me, I'm going to clean that and just make it small. All right. All students take calculus. What does it mean? Even if you don't know what it means today, but before the end of next week is going to be, all means that all trig ratios are positive in the first quadrant. All trig ratios are positive in the first quadrant. I'm recording this so you can go back and watch it. The second quadrant, sine and its reciprocal are positive in the second quadrant. So only sine and cosecant are positive in the second quadrant. All other four are negative. In the third quadrant, tangent and its reciprocal are positive in the third quadrant. All other four are negative. In the fourth quadrant, cosine and secant are positive. All other four are negative. So all students take calculus means that in the first quadrant, all 6 trig ratios are positive. In the second quadrant, sine and cosecant are positive only. I'm repeating it so that even if you hear the first time, you hear the second time. In the third quadrant, tangent and cotangent are positive. In the fourth quadrant, cosine and secant are positive. All right, so let's go back to that question. That question in number 8 somewhere. And so let's give that ourselves that question. So we are given a circle. You don't have to call it a unicircle. And that's a crooked unicircle, a crooked circle, but that's okay. So I am going to draw that point. This point here is -4, -3. Well, guess what? If I complete a right triangle here, I call this theta. And if I rewrite it, this is -4 for x. This is -3 for y. You don't really have to. If you remember, all students take calculus. You don't even have to, because you know that in the third quadrant, only tangent and cotangent are positive. Okay, so sometimes we tell you that distance cannot be negative. When you see a triangle like this, you say, what is it they were talking about? Is that, are they sure? Why is this triangle? No, it's not triangle. We're talking about the position, okay? So because of that, I am going to just get this triangle out without negative. One thing, when I finish and I find the 6 trig ratios, one thing I do know is that tangent and cotangent will be positive, sine and cosine will be negative, therefore cosecant and secant will be negative. All right, so our x is 4, our y is 3. It's not good to draw a triangle with negative side. And then the hypotenuse is r, but if you do remember, it's a 3, 4, 5 triangle, so I don't even have to solve it. We don't have all the time in the world. This is 5. I just want you to know that when you start finding sine, This time, be careful. Sine theta. This is third quadrant. Therefore, sine cannot be positive. So sine theta is opposite over hypotenuse. That is going to be -3/5 because sine cannot be negative in the third quadrant. Only tangent can be positive. Sine cannot be positive in the third quadrant. Also, find the reciprocal. Cosecant of theta is negative. Put negative first before you forget. 5/3. All right. Cosine cannot be positive in the third quadrant. Remember, cosine of theta right here is equal to adjacent to theta over hypotenuse. So you see, -4/5. Therefore, secant of theta must be negative because it's third quadrant. -5/4. And then tangent of theta, tangent is positive in the third quadrant. If you like, you can actually write it. Okay, tangent of theta is adjacent to theta over hypotenuse, -4/-3. See why? You see why it's positive? Because it's negative over negative. And one thing about tangent is that tangent theta is the same as sine over cosine. And so 4/3. And then cotangent of theta is going to be positive also, cot theta, and it's 3/4. Okay, don't forget all students take calculus. Don't forget all students take calculus. All right, so I guess we are doing our best. And then, so you should be able to solve a problem like that in that PowerPoint. You should be, this is PowerPoint, which one? Is it 9.2? Let's see what it is. Okay, so we see, and then if you see they use Pythagorean theorem to solve for R, they don't have to because it's actually a Pythagorean triple. I want you to make sure you read the PowerPoint. The angle can be in the fourth quadrant. If you know all students take calculus, you know that in the fourth quadrant, only cosine and secant are positive. The other four are negative. This is what I'm talking about. This is what we have been talking about here, finding trig ratio values. That's what we're talking about here. So we're talking about them. You can go back and read them. So you can do homework 9.1 and 9.2 today. And then this is what we are talking about. Okay, we're going to finalize some things now. So, suppose we are actually talking about, let's go back to unit circle. In fact, I need to bring back my unit circle, blank unit circle. Get my blank unit circle, and let's do something that we want to remember all the time. So I'm going to go back and get a blank unit circle right here. Right here, I put a blank unit circle. Okay, and so we called it a unit circle because the radius is 1. All circles are not unit circles. Just know that we just saw that. Okay, now at this point, we want to just talk about any arbitrarily unit circle. So I want to find the trig ratios of 30. Let me start from here. 30. This is 30 degrees. So this is 30. So the angle is 30, which I can also write pi/6, right? I hope you remember. And it's a unit circle, so the radius is 1. And if the radius is 1, remember we already know the special right triangle. Let me make this bigger. Let me make it bigger. I'll make it bigger so that. So we already know our special right triangles. Let me draw it again. 30, 60, 90. So we apply this 30, 60, 90, especially whenever it is a unicircle. And so let this be my 30 degrees. Opposite to 30 is 1. Because remember, and this is 60. And opposite to, remember that, let me make sure that we drew it the way we had it before so that I'm going to, all right. So this is my 60 degree, doesn't look like 60. And 60 is opposite the hypotenuse, and so we found this to be √3, and this is 2, and this is 1. This is a special right triangle. So I just want to carry it this way for now. That way, this is a special right triangle, and I want to make sure I put 30 here too. So I want to put 30 there. This is 30. All right, so I want to find the coordinates here. One thing we need to know is that in unicircle, the x coordinate here, when we finish that, we notice very soon we know that it's going to be cosine. Any point on a unicircle goes xy. Why do we say that x is cosine and y is sine? Why do we say that? So let me first of all find the values. So cosine of 30, sine of 30 is opposite over hypotenuse, which is 1/2, and sine of 30 is 1/2. Put 1/2 here. And cosine of 30 is adjacent over hypotenuse, and that is, I'm going to put it here, adjacent √3 over 2. Okay, but what in the world did we put √3 over 2, 60 first, and so cosine of 30 is adjacent over opposite of adjacent. What am I talking about? Opposite over adjacent, 1 over √3, 1 over √3. I just want you to know that you can, so cosine of 30 is opposite over adjacent, 1 over √3. What if it is an arbitrarily unicircle? So what if the point is xy? What if we don't know? We know it's a unicircle, so radius is 1, but we don't know the points. X, Y, arbitrarily points, but we know that this is X, this is Y. Okay, so these arbitrarily points need to be on a clear place, so that, because this is very important. So this is an arbitrarily unicircle. So this is a right triangle, and the point is, we know this is X and this is Y, and this is a unicircle. Okay, and so this angle we don't know. So we don't know this angle. This is an unknown angle. But it's an angle on a unicircle, but it's an unknown angle. So let's find sine theta of sine of that unknown angle, and arbitrarily point is xy. So sine theta is opposite over 1, y over 1. Cosine theta is adjacent over 1. Cotangent of theta, what am I using cotangent? It's first of all tangent. Let me do the first. Tangent of theta is opposite to theta over adjacent y over x. So we have seen that sine theta is y, cosine theta is x. So I can as well say that tangent of theta is sine theta over cosine theta. In other words, wherever I see a point on a unit circle and cosine of that angle is x, so cosine of theta is x, sine of theta is y. So I go back to that unit circle then, and any point on a unit circle is cos theta sine theta. Cos theta sine theta. Therefore, cosine of 30 is 1 over root 3. Sine of 30 is 1/2. Okay, any point on a unit circle is cos theta sine theta. You know what? I think we will be stopping here after some time. I don't want to be alone so far. I don't want to lose you, but we have said a whole lot this morning. One thing you want to remember is any rotating point on a unit circle labeled xy can also be said to be cos theta sine theta. Any rotating point is cos theta sine theta. And if I reduce this unit circle and if I clear everything, I can now draw my, okay, so, and we say that this is the first quadrant. And in this first quadrant, all trig ratios are positive. We know that, we said that today. In the second quadrant, students is sine, cosine, and cosecant. And the third quadrant, take calculus, that's T. Fourth quadrant is cosine. And then every point here has positive, positive, positive. So, and here in the second quadrant, x is negative, negative, positive. In the third quadrant, negative, negative. We will say a whole lot again, negative, negative. And in the fourth quadrant, we have positive, negative. Okay. All right, so I'm just going to ask you if you have questions now, because we're going to solve one more question, one more problem, and then we are done for today. We'll solve one more problem and we are done for today. So let me ask you, is there any question? Any question? If you do have a question, you can ask, or you can stay behind and ask. If you need questions, I will come stay behind when it's time. We got 9 minutes more, so don't be in a hurry to leave if you have a question. But we're going to solve one more problem. Where there we are going to apply all students take calculus. We can apply the 6 trig ratios. Everything we have learned today, we're going to apply it there. So let's solve one question and we're done. We'll solve one problem in section 9.2 and we are done. Okay, so in this question number 5, this is section 9.2. By the way, every section has answers because this is a practice. See, it is section 9.2. Actually, it's a practice test. Okay, so this is a practice test. And we are given a point. I already said today that every point on a unit circle is cos theta sine theta. And by the way, this is the fourth quadrant. And the coordinates of this point P, you are expected to do this next class. All right. But one thing is, you are given a point, 3 over 5 and negative 4 over 5. And that's all you need. Every point is cosine of theta, sine of theta. This is the easiest question in the test you're going to have. The figure at the right shows an angle theta. So this is an angle theta. Let's make that angle. Let's make that. This is the angle theta. And by the way, the angle they are talking about is actually the angle in a standard position. But what I'm trying to do is find the reference angle. Before we continue, I will just say that the reference angle is the acute angle in that quadrant. Before we continue, let me just make sure. Look at the reference angle. The reference angle in the first unit is that theta. Reference angle, let's draw it here. This is called reference angle. I use phi. Phi is not the same as theta. Reference angle in the second quadrant is equal to 180 minus theta. Reference angle in the third quadrant, phi is equal to theta minus 180. The reference angle is called the acute angle in that quadrant. By the way, when you go to the fourth quadrant, the reference angle is 2 pi, which is 360 degrees, minus theta. And by the way, remember that this is equal to phi. Phi is the reference angle. Okay, so let's continue. Let's finish what we are saying. So now in the I'm told to find the 6 trig ratios or for whatever. The important thing is that the first point is cosine theta, and that's the answer. That's the answer. The question is going to be, well, this angle is in the fourth quadrant. Is cosine going to be negative or positive? It better be positive because all students take calculus. All students take calculus. Cosine is always positive in the fourth quadrant. Therefore, cosine of the theta we are looking for is the ratio 3/5. You're not doing anything. You're not supposed to do anything. That's it. Sometimes, if you know what you're doing, some questions are not to be solved. Some questions are just to check and see if you are paying attention. So, cosine is 3/5. Likewise, secant is 5/4. They're all positive because the angle I'm talking about is in the fourth quadrant. That angle is in the fourth quadrant. Therefore, cosine and secant must be positive. All right. This is sine theta. Sine should be negative because the rotating angle is in the fourth quadrant. And so the ratio is negative/5. For sine, if you're told to find the 6 trig ratios, then cosecant is negative/5/4. If you want to find the tangent, tangent is sine over cosine. So what is tangent theta? Tangent theta better be negative because tangent is negative in the fourth quadrant. And what do I have? Tangent is sine over cosine. So 4/5 divided by 3/5. Okay, so 4 divided by 4. I have negative though because it's tangent in the fourth quadrant. I'm dividing. Instead of divide, I will just say multiply by the reciprocal, 5/3. And therefore, tangent of theta is -4/3. So there is nothing to solve in a question like this on the test. Sometimes if you see somebody solving something and has a page, sweating, and has a page, and if you don't finish the test on time, it really means you didn't manage your time very well or you did not study very well. Because that test is not supposed to last for 1 hour. But I give you 90 minutes, 1 hour, 1 hour, 15 minutes. Actually, 90 minutes is 60 plus 30. Yes, 1 hour, 30 minutes. So what I'm trying to say is that I give you 15 questions and 90 minutes. The questions you can finish in 90 minutes and make an A if you know what you're doing. That you don't have to use your calculator all the time. There are times you don't need to waste your time. I will soon show you when it's time to use calculator, but not now. So if you understand what I said today, you already know that question number 5 is a question that you don't need to solve. All you need is, I know that all students take calculus? Do I know how to find the reference angles? So I already said that reference, let me write it again. How many minutes do we have? Oh, we got, anyway, reference angles. All right. So in the first quadrant, reference angle is the same as the theta. In the second quadrant, reference angle phi is equal to 180 minus theta. 180 minus the original angle. In the third quadrant, the reference angle is theta. Reference angle in the third quadrant, phi equal to theta minus 180. 180. In the fourth quadrant, reference angle phi is equal to 360 minus theta, the original angle. And theta is the angle in standard position. And if an angle is in standard position, it goes in counterclockwise direction. We're done for today. I said a whole lot, but you can go ahead and study sections 9.1 to 9.3 and try to solve the problems there. I told you ahead of time that this is a fast track class. Let me know if you do have a question. If you don't want people to hear your question, you can stay behind and then I'm going to answer your question. I'm going to